All right, good morning. So today we're going to start the OOP review, and I will try not to repeat as much as what's said in the tutorial videos, but I think it's important to highlight what you're really supposed to know in order to learn the stuff later in the course better. Just before that, I'll just give you some very quick reminders. Your priority now should be to finish Lab 0 Part 1, right? I'm hoping that everybody has already started, and this is a priority right now, okay? And sometime today, I'm also going to release Lab 0 Part 2, which will be a continuation of Part 1. However, Part 2, over there, I will encourage to really pay attention to reference type attributes. That's really something I'll go very deep in the Part 2. I'll also try to highlight some important subjects related to reference type attributes, especially single valued versus array valued. That's something we'll talk about in the class as well. It's so crucial. And another thing would be for tomorrow, the scheduled lab session on Wednesday, I will be there, and to really encourage to come, I will try to do some interesting demo on the Eclipse. So you guys can come and maybe gather in one of the rooms, and then we'll do the demo. Not long. I don't want to take too much of your time. Possibly about 10 to 15 minutes. Especially what I plan to do now is I want to give you some idea about helper methods. So helper methods is not strictly OO. The concept exists in any programming language, like a procedural, like a C, or maybe Fortran, back in the days. So this helper method idea is more to do with the design of your code, which is not strictly OOP. However, I would like to talk about it, and you can apply it right away, maybe in your lab number 1. Whenever you find that there's certain parts in your code that can be reused, you should really consider helper method. It's going to result in very reusable code for your code to be maintainable. That's something I'll talk about tomorrow. Please come, either the morning or the afternoon. I'll repeat the demo twice, okay? Okay, so that's about the reminder. And let's now get to what we are supposed to cover. My plan is to take today, Thursday, and next Tuesday to complete a review. We'll see how much we can really finish. But as I said earlier in the announcement before the past weekend, so for this slide here, it's pretty much self-contained. For quite a good part of it, I'm going to assign you for reading. Don't worry, it's very straightforward to read. Of course, if you run into any issues reading it, you should really get in touch with me. Either schedule live session, office hour, or just schedule the appointment. I'll be more than happy to clarify. But in a class, as I promised, I'm going to do something a little bit more example-based and to really to illustrate. But today, it's going to be Eclipse heavy. I'm also going to do some demo on some small example. I think for many of the for many of the basic ideas for OOP, it's better to use an example to illustrate a lot of them. Okay? But for the first part of the lecture, let's do a little bit slide showing, a little bit, not too much, and then get your iClicker ready as well, right? We're going to do some trial attendance today, maybe in about 20 minutes or so time, but just get it ready. Okay, let's now start. All right, so that's the refurbished store. You're going to do the tutorial walkthrough, right? That's a required tutorial for Lab 0 Part 1, Part 2, just including a link here. And this is the optional tutorials if you want to explore more about the basic. Especially if you are not so familiar with the Eclipse, refer to it. It definitely teaches you from scratch. And also debugger. I will try to do a little bit debugger in class today, but only to the very limited extent. I'll try to do maybe a little bit more tomorrow in the demo as well. But it is important for you to really practice the idea about debugger. Debugger, again, is not unique to Java. It's actually relevant to any software developments you want to do. Any programming language you're going to program in, they have certain IDE, integrated development environments, and they do support the idea about debugger and breakpoints. So you can refer to this tutorial, optional but encouraged, and other subjects as well. And these are the 2 PDFs that are actually required for you to go over. I cannot emphasize more. Both of them are important. Document number 1 is about how you can infer Java code from JUnit test cases. That's what you're going to do for all subsequent labs, number 1 to number 5, and also for all your 3 programming tests. So important for you to go over that. And the second document there is talking about reference type, especially if your reference attribute is of array type, primitive array, square brackets. That's something that, that's also discussed in the document. I'll refer you to read it. If you got trouble, come to me. Learning outcomes for the review. So we're going to talk about object orientation. I will try to maybe clarify again, maybe from the more philosophical point of view, what's really object orientation? There are certain things that belong to object orientation that's beyond the scope of this course. In this course, you're given something right at hand without having to figure out certain details. I'll clarify that when I get there. Object orientation. And then whenever you want to think about classes, they are simply just templates. You're defining a single template that can be instantiated into lots of instances or objects. Okay. And well, exactly. So templates and instances, right? We're going to talk about this keyword, the new keyword, and how you can use a dot notation. For example, object1 dot some method. Okay. And also, I think today and a good part of Thursday, we're going to cover these by using the example. And maybe starting from the later part of Thursday, we're going to do a little bit more reference type attributes. And aliasing. That one is also very interesting. That's my favorite subject for OOP. Once you get to the aliasing part, that's really unique. You don't really have aliasing in procedural language like a C. You don't really have it. Well, to be more precise, you can simulate it using pointers, but you don't normally do that. But for any true OOP language, you have to watch out for aliasing. Aliasing, on the one hand, is pretty tricky to really get right, so that's why I'm going to show to you how you can trace the code properly. On the other hand, it's really good code practice whenever you can use aliasing for space efficiency and also for maintainability of your code. That's something we'll get to. Maybe not today, but maybe Thursday. Before Thursday's class, I will also try to give you some exercise to really try on your own. That one is more like an example quiz question or test question. So you can feel free to try it out yourself before the class. All right, also we're going to talk about non-static versus static variables. That will be the last topic to review. Okay? Helper method, I'm going to talk about it in the lab tomorrow, just to give you a demo. All right. All right, the first line here, just about the separation of concern, right? We talk about, we got model. If you already have gone through lab 0 part 1, right? We have this clear separation. We got model, which will be coding the logic of your particular application. We call it business logic. And also we got controller. If you want to maybe just print out to the console what the output should be for individual method, that will be controller using the main method. Or you can have some tester using JUnit test, right? You got either way. However, I would really encourage you to really get used to the second one over here. That's really the way to lead you far beyond this course, okay? All right, in Java, so we got classes. Oh, this is important. I'm not sure how many classes you have really seen back in the first year. It might be to your kind of maybe to your habits, you're only dealing with a single class. No, it's the opposite. In OOP, dealing with only a single class, we call the Superman class, is very rare and very bad practice. In OOP, which I'm going to gradually show you, especially for lab number 1 and 2, you are going to have to create about 3 or 4 classes yourself and see how they can interact with each other. When you get to the level like a 3311 later, you may have to deal with maybe close to 100 classes for your big project. Well, one step at a time. You just have to keep in mind, in OOP, it is definitely very common to have more than 1 classes. Very common. And of course, we declare methods, and we'll see how they can interact with each other. So classes, declare templates, objective for instances. And at the runtime, we gotta create various objects, which I'm gonna show to you today. And also you gotta call the methods on the right objects. It's context sensitive. I'll explain to you what that really means. And also you're gonna simulate some interaction around the real world in your code. That's something you gotta do. Either on the control, either in the main method or in the JUnit test cases. You can do either way. And let me just remind you, there's a diagram here. I believe I included that in the lab, right? So this is rather straightforward. I'll just keep that as a reminder for you. Always remember, we have a separation of concern. Separation of concern is always a good practice to really think about In one unit, you only deal with one thing and do it well. Model versus JUnit testing, and also console apps. But for your programming tests and labs, I'm hoping that you will only focus on these two. This one here, gradually you want to grow up and get rid of it at some point, conceptually. All right, I'm going to let you read the detail. It's also mentioned in the labs. I'm including here just for your notes. Guys, any questions so far? Okay. Yeah, sorry, a little bit more slide showing before the break, but I do want to just make sure you're somehow guided about how to study the slides. But the next one here, I want to spend a little bit of time explaining the philosophy of object orientation. I'm not even talking about programming. You want to understand the methodology about object orientation before you can program in some object-oriented language like Java. Okay? The way I put it, there are 3 stages. You first of all have to observe what's really happening in the real world. And then you have to somehow translate whatever you have observed in the real world and model it into a programming language, such as Java. Once you have modeled or you have programmed everything in Java, let's say that's your chosen language, you're going to somehow execute the relevant coding in the runtime. So these are the 3 phases. Always keep that in mind. In this course, we don't really do much about the observe part. So this part here is a little bit more, the principle itself could be a little bit vague. It's really up to your experience as a software engineer. So for later course, like a software design, 3311, or software engineering requirements, 4312, you're going to have much more rigorous practice on this. So I'm going to save that for your professor later. So what we're going to focus on this course will be model and execute. We'll go directly to the Java. For your labs and also for your programming test, usually we tell you the result already from the observation. So you don't have to observe the real world, which let's save time. All right? But let me just dive a little bit more into details. So the status diagram, I'm going to go into it. I'm going to just give you some simplified presentation in this class. But if you want to see a little more detailed account of this, you can feel free to click on the link, optional. Okay, that's another tutorial video, optional. Okay, we're going to observe, model, and execute, right? So you can read the bullet points. Let me show to you some example over here. How do you read a diagram? I'll also give you a standalone version of that diagram. You can feel free to print it out or save it somewhere for your future reference. So we got 3 stages here. We got observe over here. We got the result of the modeling. We got the result of the execution. Number 1, it would be very important for you to realize, number 1, here, we'll talk about compile time. Versus over here is runtime. Right? It's really important to tell the difference. Compile time means you're still writing the code. It's still doing the developments. Developments of code in some editor. Could be IntelliJ, could be Eclipse, can be whatever editor you're using. And once you get to the runtime, number 1, there is a big assumption. Given that whatever you develop compiles. So the machine can actually interpret whatever you type and try to execute it, right? And then you're trying to execute. So it is so important for you to understand compile time versus runtime. All right, let's make it clear first. Let's now look at some example here. Okay, let's now talk about 2 scenarios. Scenario number 1, we are observing 2 entities over here. Let's say this person here, let's say Jim and Jonathan. Let's say, hope nobody is called Jim and Jonathan in the class. I don't want to offend anybody. If yes, I'll change the name. Okay, good. Jim and Jonathan here. Okay? Apparently, they are different entities. Agree? But they share similar or the same attributes. It is important to have this conclusion. They are different entities of the same kind. So when I say they are of the same kind, what does that mean? That means they will have certain common attributes. And also some common behavior. Are you comfortable with this part here when I say they are the same kind? What can be the common attribute? Let's say, for example, it could be that maybe, okay, so here entity we got Jim and Jonathan. For the attribute, it could be their weights and also their heights. So Jim has weights and height. Jonathan also has weight and height. That's what they share in common because they are entities of the same kind. But how do we distinguish between them? You look at each individual attributes and see what's the entity-specific or instance-specific value. All right? So here, if you look at here, inquiries over here. So you have some instance-specific. Sorry, let me write it a little bit more properly. Instance-specific values for attributes. You know, for example, let's say for the height, for both of them. And in this case, Jim may be higher, 1.8 meters, and for Jonathan, slightly shorter, could be 1.7, right? They share the same height attributes. However, their individual height values are different. You really want to tell this difference here I'm talking about. That's so important for your understanding. And in addition to this, they also share some common behavior. So for example, they might change their weights, they might gain weights, they might lose weight. Both of them could. But the consequence, for example, for Jim losing weights would be different from the consequence of Jonathan losing weights because their starting weights would be different. That's instance-specific value, right? So behavior could be, for example, change weight. All right, and overall, once we have seen so many interesting facts about these two entities, ultimately, we may just want to say there might be more than Jim and Jonathan. There might be Peter, there might be Jackie, there might be Alan. There are so many other entities of the same kind. So what we want to do is to have a single template to describe all these entities. That's what we call a template, or in Java, it's called a class. In this case, we can just make a person. Guys, are we okay? So I'm talking about how to observe. And also, we are smoothly transitioning into how to model in the second stage. Okay. Good. All right, so now another one that will be exercise for you. Let's say, I'll get to the diagram. I'll get back to it in just a moment. So what will be the exercise for you to try? I want you to now take a look at these different kinds of entities. Let's say we talk about two-dimensional plane, which you are very familiar with, from your math class. Let's say we got two entities, 1 and 1 over here. So you can see over here, we can observe one point is maybe 2, 3. The other point is -1 and -2. Apparently, these are two entities of the same kind. And that kind is a different kind compared with person. Agree? Sorry. So this kind of entity is different from this kind of entity. That's why we got so many different classes in Java. Every class describes a particular kind of entity. All right? So now here, exercise for you. Given that we can observe these 2 points, can you now talk about what are the entities, what are the attributes, what are the changes we can make, what are the inquiries, or instance-specific attributes, what are the templates? All right, exercise for you. You can give it a try. Very easy to try. All right, finally, I want to make a remark. Back to the diagram. What I have done, phase number 1. We have one set of entities, Jim and Jonathan. eventually we're going to model that into something we can programmatically manipulate. In this case, we're going to translate them into the person template. So that means later, Jin can be instantiated from this template. Jonathan can also be instantiated from this very same template. And similarly, if you look at the different points and also the corresponding template or class in Java. Okay? And now, if you look at stage number 2, that's kind of the Java class you want to build. And you can see there's a really close connection between how you observe and how you decide to model. Really important. Of course, this particular action here is based on experience. In this course, you will be given what you're supposed to model, pretty much. You'll be given the hints from the JUnit test cases. Okay? Finally, let's say we got this, let's say for this particular template. So this is the template we have created. What we have is at the runtime, we can create different instances. This is instance number 1. This is instance number 2. And not surprisingly, you can think about this instance here is corresponding to maybe this guy over here. And this instance is corresponding to this guy over here in the real world. Right? We just computationally try to simulate what's happening in what we observe in the real world. All right? And I'll talk more about how you can visualize individual objects in the memory. There is the more like a lower level way to do it, and there's more the higher level to do it. I'll talk about both. Okay? Both are important. Oh, I beg your pardon. I definitely make some very, very terrible mistake. This is a P1, right? That shouldn't correspond to it. I'm so sorry. What I really meant to circle will be this one here. Let me just do it. Otherwise, you will be confused. Jonathan here. And of course, that one is going to correspond to this guy here. That'll be right. Sorry about that, in case you might be wondering. Okay, so this might be the only time we're going to talk about like a philosophical remark about object orientation. If you haven't heard about this before, good for you. So make sure you understand it. All right? Any question about this? Yes?
So how to decide which attributes or behavior we should include?
That's a very good question. I think for individual labs and also your programming test, we will be requiring about what methods and classes you have to create. I think for attributes, you have some freedom about how many attributes you want to create. But I would say typically they're quite standard. For example, if let's say for person, if I have some method called getWeight, that would suggest you should have a weight attributes in the class. Right? So I would say look at what methods you may invoke on this particular class or objects, and you can refer back to see what attributes I might need to store the information for the objects.
So
Yeah.
it's like a reverse.
A little bit like a reverse engineering. Think about what you might need for this particular kind of template or objects, and then refer back and then reverse back to see what attributes you might need. I may talk a little bit more about maybe later when we see the example. Okay, let's now move on. This page over here, I will also include it as like an information sheet for you just to review, different concepts. We're going to talk about many of them. We already talked about the difference between compile time and also runtime. Sorry, compile time and also runtime. Attributes, right? There will be common around instances, but at the same time, each individual attributes may have different values among different instances, right? Also, we got methods, which I'll talk about every one of them by using the example, right? Just remember. Accessors, mutators, or sometimes people say getters and setters. Accessors, mutators are a little bit more general term. Getters, setters, maybe a little bit more to Java or other language which use get something or set something. So you can use either one, that's okay. And something called refactoring. That's something maybe when I talk about the helper methods tomorrow in the lab, I will demonstrate more. Whenever you hear people talk about refactoring your code, that simply means to change your code. Okay? Let me save this maybe for tomorrow a bit about refactoring. But a very typical thing, what are the typical things you can do? You can rename. variables. Or you can rename your methods, just to give you some example. But when we talk about helper methods, it's a slightly more complicated way of doing refactoring, which I'll talk about tomorrow in the lab. All right, so we also got constructors, and also we got a dot notation, right? One thing just as a look ahead. Maybe back in the first year, you're very used to, let's say I got some object obj, and then I can say dot certain method, for example, right? As we will see, the dot notation is a very powerful mechanism in OOP for you to navigate among the different classes. Remember, we talked about there are more than one classes in your developments. So once you got multiple classes, they are somehow connected with each other. The way to navigate among the classes is by using the dot notation. So don't be too surprised later in your lab, possibly in lab number 1 or 2 already. Sometimes you may have to do things like, I'll just sketch, objects.m1 and then .m2. Or this dot can go forever. I shouldn't say forever, can go as long as you might need it. Okay? So dot notation is not just, you don't always see just a single dot. You might see multiple dots in your code. So that's why you got to understand what the dot really means. All right? All right, so this one here is just an exercise for you, right? I'll leave that to you. Basically, the principle would be, if you're more interested in the observe stage, which I said would be beyond the scope of this course. So you can, for example, look at these two informal English descriptions about different problems. And now from there, how can you invert what should be the classes to create, what should be the attributes to create, and what should be the accessors versus mutators that should be created. That exercise is fun, but beyond the scope of this course. We'll always tell you the decision we have already made because it's a different focus. Once you get to software design, software requirements, that's basically what you got to do. Okay? But for this course, not too much. Okay? And you can also see some principles on the slide, which I can assign you to read. Okay, so this is something we talk about, right? Yeah, just go over that. Everything has been talked about. I'm not skipping anything, just in a different way of presentation. All right, so that's basically example number 1 about the points. You can read through the informal text, and before you see the slide, think about what you may observe from there. If you believe you have a different but still valid solution, after reading this, let me know. We can discuss, right? All right, that's example number 1. I'll let you go through. That's, just about, one thing I can do together with you, just for clarification, since I created the page yesterday. Okay, I'm going to do a table. Okay, again, let me do the person example. Since the in-class code demo I'm going to do today also is related to person, but I'm going to leave the points example to you later. Okay, so that you will understand what we're doing here. This column here, which I'm going to do, is related to this, example number 1. What I want you to do as exercise would be to fill out this column here in the similar way according to this example over here. All right, that's what I want you to do. But let's now go to this column only, just to summarize what we know. We're still talking about object orientation, not Java just yet. It is so important to clarify philosophically what various concepts really mean before you get to the syntax in Java. All right, what about templates? Well, we have a person template. So what are the common attributes that every entity in the same template actually share? They have the weights and also the heights. And in order to really make the programming sense, you normally have to give a type. What type is that, right? What type, guys? String? Integer? Sorry? Double? Yes. Why double instead of integer?
So like it can have points.
Yes, the fractional part. It can be maybe 60.5 kilograms, right? Very good. So I'm just going to put double here for now. Also double here. So these are the keywords in Java. And what will be the common behavior? So these will be the methods, in which case we're going to include maybe the headers or the API, right? Just for example. It could be we can get the weights of somebody, some person, just example. Or it may be something that wouldn't change anything. Sorry, it might be something that wouldn't return anything, but it's going to change internally the objects. We can say maybe gain weights. In which case, we might have to include what's the new weights. Right? One more. Or it could be that, rather than, also back to your question before. So in this case, to really get the weights, so you kind of know that, oh, maybe I should really have weight attributes in my class, right? On the other hand, we can have another one here. Let's say it's going to return the double. And we can maybe get the BMI. Not too sure you want to know what it is. It's called the body mass index. It's just a formula to be calculated to see like a measurement of your body, calculating using your weights and heights. That's something I'll do today. Okay? It's just an example. All right, so now what about instance specific attribute values? So it could be that we have instance number one, or object number one. Let me move on to a little bit more Java. It could be object number one versus object number two. All right? It could be that object number one, the weights is maybe 46.3. I'm making that up. And for object number two, they also has a weights, but it could be something different, maybe 70.7. Right? Different values, instance specific. And now, because the attribute values are depending on the instances, if you want to see the behavior of individual objects, since their attribute values are different, the behavior can also be different. For example, let's say this. Let's say for object number one, dot gain weights. Let's say gain weights by 2. All right? And at the same time, we also got object number 2 dot gain weight, also by 2. Right? We'll see a lot of instances, we'll see a lot of examples like this. Now, I want you to look at very closely. I can emphasize more. Think to yourself, if you look at these two lines, how are they the same? And how are they different? This is so important. I know it's like a dumb question, but I still want to make sure you understand what I'm trying to say here. Okay? Can anybody tell me, how are they the same? The same. They're invoking the same method with the same input value as well. Good? Very good. Number one, this part here would be same method with the same. Let me say input just for now. Okay. Invoked. Okay, let me go back. How are they different? They invoke on different instances. I like the answer, but now let's review. There's one formal term for this. How do we refer to object 1 and object 2 in each individual method call? There's a way to refer to them. Context objects. All right, I'm going to use this term throughout the course. Okay. Okay, object 1 and object 2 over here, they are different context objects. Context. In OOP, everything you want to trace the code is about context. Object 1, object 2. And because we know object 1 is corresponding to this guy here, by giving 2 kilograms, for example, we're going to get from 46.3 to 48.3, which is a different consequence than Object 2, who is 70.7 heavy, after gaining 2 kilograms, is going to be 72.7. Apparently, they're different, even though they're invoking the same method. All right. All right, any question about this? All right. If you're finding all these too trivial, too easy, good for you. I'm happy. But I still got to go through just for everybody for the review. All right, exercise for you. Over here, please do this exercise over here for example number 2. That's going to be good for you for conceptual clarification. Exercise. And if you want me to check your answer, drop by, office hour. More than happy to go through. Okay, good. All right, so everything has been covered, so please read through them. Just make sure you're comfortable with it. Classes, templates, right? So that's about the a little bit more to the Java syntax, right? We're gonna do everything in the code demo, so don't worry. All right, just I think I got 2 more slides to show to remind you something about Java data types, and also I want to clarify about 2 things. One is about parameters versus arguments, and also talk about the scope of the variable. Let's do these 3 things, and then we have a short break. How about that? And then we can do code demo. I don't think I can finish everything I want to demo, but we'll continue on Thursday. Okay? Good. Let's talk about Java data types. This should be also something you have known about from first year. Whenever we talk about a data type, a type, it basically tells you if you declare, okay, no, I think it's always good to give you some very clear definition. Okay, let's start with this. In Java, each variable must be, you have no choice, declare with a type. And for those of you who took, for example, 10, 15, I guess for MATLAB as well, correct me if I'm wrong, I believe for Python and also for MATLAB, you don't necessarily have to give a type to the variable. But in Java, sorry, you have to. Okay? And number 2, let me just give you some example here. For example, you have integer I. Also, let's say, if I declare, let's say, person, P. These 2 are variables. When you declare I and J, you must declare its type at the same time. In some way, you're committing to what you might ever store some value into I or P accordingly. The Java compiler is going to make sure they enforce this. Okay? Let me just go with the second point. A type denotes the set of values that is allowed to be stored in that variables. So these 2 points, you really look at them at the same time. All right? How about this? A declare type. For example, here you can see I declare I to be integer. Somewhere in my code, I can say I is assigned to 23. I can reassign to I is reassigned to 46. But as soon as I say something like, for example, I is maybe 36.7. No. How am I going to say no? Of course, you can do like a cast if you want to, but let's not worry about it for now. All right? Or if you say I now should be assigned to maybe P. But the problem is P was declared as a person. Int and person are not the same type, so you cannot do it. All right, that's kind of the checks compiler can do for you. All right. A little bit look ahead. Lots of fun when we're going to talk about variable assignments over here when it's reference type. So over here, later on, we're going to see when you say P is assigned to another Q, for example. Okay, I'll just give you a little bit look ahead, but we're going to come back to this idea in much more elaborate discussion after the reading week. So we know that P over here is a person. Intuitively, if you want to assign Q into P, what should be the type of Q? Person. I agree. There's another option here, which requires the knowledge about inheritance. I'll just put it for now. So don't worry too much. If you understand one, that's pretty good for now. For number two, it can be any class that's declared as a subclass of person. Okay, that's something I want to just mention now, but you can review this. Maybe when you review this in the exam, when you see this second point, let's say 3 months from now, that will make sense to you, since you will have already learned about inheritance. Okay, 2. All right. All right, guys, are we okay with about the type and also about the runtime values? Okay, clear? Let's go back to the slides. So we got primitive types. It can be integer, floating point, can be character, can be Boolean. Oh, did you notice that I missed string? Am I making a mistake? Should string be a primitive type? No, string is not a primitive type. Whenever you talk about integer, numbers, or character, or Boolean, we are not really talking about objects. We just talk about primitives, like a simple value. Anything that's not primitive in Java is reference, including the string. All right, and whenever you talk about reference type, what can you store in the reference type attributes? Let me just go to another iPad notes just to remind you. Okay, I think that's something I briefly mentioned when we look at a review question, right, back on last Thursday. But I'm going to talk about once more. Let's not worry about array just yet. Let's make it very straightforward. If I say integer I versus if I say person P. Okay, first of all, this integer over here is a primitive type. And the person over here is a reference type. And the reason that person is a reference type is somewhere, either in your project or in the Java library, somebody declared this class. A class that's declared. Somewhere. Could be in your projects, you did it yourself, or in the Java API library, either way. And the difference is that, let me just tell you right away, right? Let's not worry about asking you, just for now, just to save time. This one over here, at the runtime, I can store any integer value. And the way to look at this, I here, maybe initially I want to put 23. And later on, I don't like it. I can replace it by 46, and etc. Easy. And now, what about this guy here? Right? As we briefly mentioned on Thursday last week, at the runtime, what can P store? It can store the reference or address of some person, instance, or objects. Okay? At the runtime, I can store the reference or address of some person objects. Okay? There are two ways to really visualize this. I'll mention that right away, but we're going to review it again. Either you can draw it like this. You can say P over here stores the address, let's say 06123, let's say. That really corresponds to the computer memory somewhere over here. Okay, let's say this is the address. Oh, sorry, let me just make some space for myself. How about here? So let's say it's 06123. So this is the part of the memory we are referring to. So the P itself does not store the entire object over here. We only store the starting address of the objects. So it's kind of indirect. That's one way to visualize it. But you definitely don't want to visualize like this in order to trace your code in the past. You're going to be too slow. The way to do it is something like this. The way to do it is you're going to say P is a variable, reference type. That one is indirectly referring to some memory location which is instantiated as an object of type person. And that person there has the weights, has the heights, attributes, and then you got different values over here. So you got option number 1, option number 2, okay, to trace what's happening here. Right? Right, quick recap. Primitive type versus reference type. You have to be very clear about what's really stored in the primitive attributes versus what's really stored in the reference type attributes. And then, especially for the reference type, we are storing the address, not really the entire objects. All right? Let's go back. Okay, good. Data types, and then, yeah, so we got idea about default value, for integer, for numbers, it's simply 0 or 0.0, depending on the type. And also Boolean, the default value will be false, okay? And then for the reference type, doesn't matter what type it is, it's always null. So that's why we have this very famous or notorious error called null pointer exception. All right? I'm pretty sure you guys will run into it quite often in your labs, which is okay, it's part of the learning. You may crash your code by null pointer exception very often. Even for experienced programmers out there who have got lots of experience in the working place, they can still run into this null pointer exception. Okay? What's really, well, very quick. Whenever you're trying to make a method call, let's say obj dot some method, and then maybe some value over here. So what can cause a null pointer exception? Basically, what you're saying over here is, I want to invoke this method here on this particular context objects. But what if the context object itself does not even exist in the memory, which means it's null? In that way, you got null pointer exception. Okay? Again, this is called the context objects. If the context object is null, that means you got null pointer exception. Of course, one way to prevent it, but you don't necessarily have to do that every time, would be you might say if my obj, if it is not equal to null, right? In that way, I can make the method call. That will be saver. obj dot m. In this way, it's guaranteed this is free from null pointer exception. Because if you could get to this point, that means it is not equal to null. Agree? Okay. Guaranteed. No null pointer exception. All right? So if you really don't feel safe, sometimes in your code, in a particular method call about causing null pointer exception, you can feel free to use the if statement, but it's not a very good practice because you don't want to surround every method call in your method, in your code with this if statement. That's going to pollute your code quite badly. So I would say only use it with caution. Okay? All right. All right, that's about the slides. And then, okay, let me just tell you something here. Starting from slide number 16, from slide number 16 all the way to 47. You know what? Let me just have a new page. Otherwise, I don't want to confuse the two. Slides 16 to 47. Okay, you can do self-study. But we're going to cover many of them in the code demo, which I'm going to do today and also Thursday. But you can definitely definitely don't have to wait for me. All right. And let me cover another two things very quickly. I think we can leave some room for break briefly, and then we can talk about some code demo. I think we're still doing okay with the time. Okay, bear with me. I want to talk about two things. Number one, parameters versus argument. Sorry, parameters. Okay. Sometimes people don't like to distinguish between the two, but I think it's rather important to know. When we talk about parameters, what do we mean? And when we talk about arguments, what do we really mean? They are not really the same, strictly speaking. Let's take a look. Very easy to understand or even to remember if you need some tips. Whenever we talk about parameters, we're talking about when we are defining the template, especially when we're defining the method. Okay, parameters has to do with definition. So here you can see this other over here is a parameter. And also this one here, direction, and also units over here, these are also parameters. Because we are mentioning these three variables in the context of defining these two methods. They are parameters. Okay? Arguments, on the other hand, are referring to those values or expressions that we want to pass when we want to call these methods. For example, if you want to call this particular method, the definition tells you you need to pass some point objects or reference as input. Whatever input you actually pass is called arguments. It's a different context. It's about usage context. Or here, if you want to make use of the move method by invoking it, you have to pass a character and also pass a double, right? Input 1 and input number 2. Both of them, when you use them, will be arguments. Let's see. Let's now take a look at here. Okay, let's do this one here. I'll talk about how you can trace object creation a little bit later, okay? But at least for now, you know that we got P1 and P2, okay? They're both declared to be point type. We're talking about points. And here we got this method invocation. We got this method invocation, right? So now I want you to make a very clear connection here. P2 and P1 are the inputs, different inputs for the same method call, right? They are arguments. And somehow they correspond to the parameters over there. Can you see the connection here? Let me show you again. Other is the parameter. When you're trying to call this method for as many times as you like, each invocation requires a single argument of type per point. In this way, argument number 1 is P2. Argument number 2 is P1. Okay, arguments versus parameter, right? Rather clear, right? And another example here, let's say I'm trying to call this method here move. And you can see that this is one argument. This is another argument. And then how do we relate back? This one here is corresponding to the parameters over here. This 7.6 over here is corresponding to the parameter over here. Because we are expecting this particular input to be character, so it must be a character. Because we're expecting this particular parameter to be units, so when we pass the argument, it must be a double, matching the type. All right? You will see lots of context, like lots of examples, like, oh, well, for every method call you make. Always be clear about what's really the parameter that you can refer to back in the definition versus the argument you have to pass. Maybe right after the reading week, we're going to talk about a concept called call by value. And we're going to use the parameters argument very badly. So if you can learn it now, that's great. Guys, any confusion or anything that's not clear about parameters versus arguments, please? Everyone's good? Okay? Don't be shy. One final thing before we take a short break. The scope of the variables of a class. I included some principles over here. So here, let's assume we don't talk about anything that's static. We'll get to the static, which will complicate the matter a little bit at the end of the review. For now, let's assume everything is non-static. Okay, just for now. If you don't even know what static is, don't worry. So that's good. That's good for this particular example, right? Just don't worry about static. So we talk about class level variables or attributes. They can be used between methods. For example, here, let's say we got a class called myClass. We got two attributes, I and j. This is what we call class level variables. I and j over here, class level. They may be used in any of the methods. For example, here under M1, which is one method here, you can say I is assigned to 23. You can do that. Or under M2, you can also say, for example, j, let's say the same I, is assigned to 46. Or it could be that I have some local variable over here. I can say n is assigned to I. That's also fine. That's why I said about access versus modify, right? You can do either. So you can see access, which corresponds to using its value. What can be modified, you can see I'm modifying I to be something else, right? Either way. All right, that's one rule you should know. Whatever you declare at the class level, it may be access or modify in individual methods. Rule number 2. If we got parameters in the definition of the method, they may be accessed, but not modified. You can try to write the code to modify it, but it has no use. And Eclipse is even going to give you a warning. I'll get to that part there maybe a little bit later. For now, let's just talk about what's going to cause an error for you. Okay? So let's say, for example, let me say here, so let's say for M1, because I declare P1, that means when I invoke M1 in other context, I can pass any integer to instantiate P1. Okay? So I can say, for example, M is assigned to P1. This is good. However, can I say M is assigned to P2? And P2, by the way, was declared as a parameter for another method. No, you cannot do it. Whatever you declare as a parameter for a method, it only belongs to that method, nowhere else. Okay? So this one here is going to give you an error. That's pretty straightforward. A final example here, we talk about method level local variables. For example, let's say within this method here, I'm declaring a new variable, m. And the scope of this m here only belongs to the method that declares that, only here. Can I try to use M in here? No, it's outside the scope. All right, let me just show you that. So here you can see I'm already using M. That's good. However, if I try to say N under this method here, N was declared to be only local to M2. Can I say N is assigned to M? No, because M here is in another method. So wrong. I will encourage you, based on these 3 rules, try to reproduce another example on your own. Maybe something that's even more complicated. Anything you may have in doubts, you can reproduce an example in Eclipse and let the Eclipse compiler to teach you about how things, why they should work or not. I will encourage you to try. Or I'll let you try in the test, which means I'm going to test you on that. So like this. I might just give you a code fragment there with maybe different variable access or modification. It could be a multiple choice to ask you which one should be valid and which one should be invalid. I think that's rather important, okay, without the help of the tool. Okay, give a try on this on your own. If you run into any specific example that doesn't make sense, reach out to me and then we can discuss. Guys, are we okay so far about scope? Okay, we haven't really talked about static variables, which we'll talk about maybe next Tuesday. Static variable is not going to make the scenario too much complicated, but you just have to gotta watch out on what's the consequence of using static variable. But we'll talk about it a little bit later. I think up to now, it's pretty good. I think the next step is to really do code demo. I'm hoping to do some today. We can have at least 15, maybe 10 minutes or so, or a little bit more than that. But for now, why don't we try taking attendance? Okay, let me stop the recording now. All right, let's now get started again. We got about 11 minutes or so according to my watch. So I would like to start with some Java development together with you. I'm also going to make the code source on the website also when I release the recording. But I think I'm going to use this example here. Remember before the break, I said from slide number 16 to 47, you should really do a study on your own as much as possible. But I'm going to illustrate all the core concept from there in this small example. I think it will be a nice perspective for you to learn differently. Okay, we got 10 minutes. Let's see how much we can do. Assuming that you got your Eclipse on your laptop, you can feel free to follow me along. If not, please just watch. Eclipse, okay. And then I have a workspace for 2030. A little bit slow. There we go. Okay. I'll just choose any workspace you like. For me, just 2030. Launch. And I'm going to create a new project there. Yeah, next time I'll load the project first. All right, so let's create a new Java project, which you should be very familiar with. File, new Java project here. And please be sure 2 things. Number 1, there is an option under, sorry, it might be a little bit small for you. I'm going to read it. The video should be quite clear. Under the module section there's one box for create module info.java file. Make sure it's selected. Don't select it. Okay? Number 2, for your laptop, it might give you the default version, something that's strictly higher than 21. As I mentioned earlier yesterday, in the remote labs, guys, please. Yeah, we want to allow others to also pay attention. Okay. Yeah, so in the remote labs, the highest version is 21. So if your machine choose anything that's higher than 21, you're going to have some compatibility issue when you try to import your project into remote labs. So please, for now, make sure you always check if the version that's already chosen for you is 21, you're safe. If that's 22, you got to downgrade it to 21 or lower. All right, let me give a name. I would say person. And let me move the clock a bit. Well, how about let me just remove it for now. How? Okay. Okay, the person's over here. Okay. So let's now try to play with the code from scratch a little bit. Number one, I'm going to create a class called person. New, and then class over here. Let's call that person. It's not a console application, so just person, okay? And let's not worry about the package stuff just yet. I can always refactor by changing it later, okay? And say finish. All right, and then, do you think the font size is okay for you at the back? It's okay, right? Okay, no larger? Good. Okay, so let's now do the following. So this person here is a template, right? We talked about template before the break. What I want to do now is, after observing the entities of type person, let's now try to declare two attributes. I can make some comments over here. Okay, I would say two attributes shared by all entities of type person. Always good to document your code like this, always good. The reason being, you might be the only person who knows inside out of your code. But even that, 2 months from now, when you go back to the code, you might just forget about all the details. So it's good to document your code, especially about important decision you make or rationale for declaring certain attributes. So I'm gonna have, let's not worry about private just yet. Okay, let's focus on more variable declaration. I'm gonna have double weight. And here we can say it is measured in kg, kilograms. And also we got double height, also to make it straightforward, also measured in meters. So rather than saying 180 centimeters, we'll say 1.8 meters. We got two attributes over here, and this will be the simplest template you can ever define in Java in order to create instances already. You don't need any explicit constructor. You don't need it. Do you guys know that? If you know, now will be the time to know. All right? I'll put it here. Without explicitly declaring, how about defining? A constructor, there is already one default constructor for creating instances. That's number one. Number two, as soon as you introduce your own constructor, even just one constructor, the default constructor will be gone. I'll illustrate this idea to you. Okay? Number one, I'll write it down. As soon as a customized version of constructor is introduced, the default constructor is no longer applicable. All right, so these are the 2 points I would like to illustrate first. Now, you can see there's no constructor in the code, right? Let's use the default constructor first. The way to test it will be, let's create a tester. New. Let me just say console tester. Just make it some simple output just for us to try. Well, let's say we can say person tester. And then I'm going to select the main method here, right? That's something I also illustrate in the lab tutorial, right? And finish. All right, so that's the main method here. And now let's try this. I can, even though there's no explicitly defined constructor here, I can already say person P1 is new person. Very important for you to always remember. Always check to see every class, every file in your project has no red cross. If there's a red cross, that means you got some error, compilation error. Okay? So before you submit a lab or before you submit a programming test, always make sure there's no red cross. Okay. And this one here is already making use of the default constructor. Does anybody know what the default constructor do? What does it do? Does it do anything useful?
It just initiates like the variables that we define.
Yes, it will initiate the variables we declare, which will be weight and height. To what value?
To the default.
To the default value. That's excellent. Okay. Okay, over here, it's good to note the default constructor will initialize all attributes to their default values. Another thing I want to illustrate to you, system.out.println. And I'm going to say P1 over here. Before I invoke the code, what should be the console output here? Should it be, well, as your classmate correctly said, it's going to initialize P1 weights and P1 heights to be 0 because they are numbers. Is the output right now going to be 0, 0? Sounds convincing, no? Or not? Okay, good. Normally, if I suggest something, most likely it's wrong. Could be sometimes right, but mostly wrong. You got to tell me why it's wrong. Yes, please. What is it going to print out? It's going to print out the address by default. All right? So let's see the output first. If I execute this code here, it's going to show to me some address. So this is the address from P1. Okay? And now we want to look. You know what? I'll use a breakpoint debugger maybe on Thursday. I only got about 1 minute or so. Now I want to show you one thing just for completeness. This is really creating an object already. But now, default constructor may not be exactly what we need every time. All right? So what we need is this. Look what I'm doing here. Now let's add a customized version of constructor. All right, let's say constructor, unfortunately, has to be public always. And what should be the name of the constructor? Person, the same name as a class, right? And now you can choose to add any inputs as you wish. Let's say we want the weight and height to be initialized to some value. So let's say double some new weight. Also double some new height. And then over here, let's not even worry about the definition here just yet. Now, is my project still error-free? Important. No, it's not anymore. You can see now if I go back to where I was of using the person class, you can see now what I used to be able to do by using the default constructor here is now telling me the constructor is undefined. That's the second point I would like you to remember. Let me do it again. If this customized version, sorry, that's telling me time's up. 30 seconds or 1 minute. If I don't have this customized version over here, I can use the default constructor without any problem. As soon as I adding anything I wanted to define by myself, default constructor is not there anymore. It's not always there. As soon as you introduce something on your own, it's gone. So how do we fix this? We should really add in the arguments according to what the parameters are, right? The double over here. Let's fix that, and then we're done. So for example, the P1 over here could be, let's say, weights, maybe, I don't know, maybe 79.2, and the heights maybe 1.78. Now it's back to error-free. All right, so up to now, we talk about default constructor, how we can use it, and also customized constructor. All right, we'll continue from Thursday, and see you in the lab session tomorrow.